Okay, so this is the section B of the Cosci mock. So we've got an electrical circuit for a torch flashlight. The potential difference across each cell is 1.5. We can see there we've got three cells. And so 3 cells of 1.5, 3 times 1.5, 1.5 is 4.5 volts. Okay, so state the potential difference across the lamp when the switch is closed. That will get the whole of that 4.5, so the answer is 4.5 volts. There is a current of 0.9 amps in the lamp for 60 seconds. Calculate the charge that passes through the lamp. So we should know that I is Q over T. If we didn't know that, then we do know that the ampere is coulombs per second, and so we should have been able to work out that equation. And so we've got 0.9 is equal to Q time over 60, so we end up with 0.9 times 60, and 0.9 times 60 is a value of 54, and the unit for charge is the coulomb. The lamp from the torch has a resistance of 5 ohms when lit. 2 lamps identical to the torch lamp are connected together in parallel as shown in the circuit. Calculate the combined resistance of the 2 lamps. Show your working. So we're doing the 1 over R is 1 over 5 plus 1 over 5. Oops. That's 1 over 5. 1 over 5 plus 1 over 5 is 2 over 5. So 1 over R is 2 over 5, which means that R is 5 over 2. 5 divided by 2 is 2.5 ohms. Figure 12.3 shows a circuit controlling a cooling fan in a greenhouse. The circuit includes a motor, a thermistor and a 6-volt battery. Explain the purpose of the thermistor in the circuit. Okay, so we need 3 ideas. We need the idea that we've got a high temperature equals low resistance. Low resistance equals high current or higher current. And higher current equals a faster motor. Okay, so moving on to our next question. A boy sitting on a beach is exposed to many forms of electromagnetic radiation. Figure 3.1 shows an incomplete electromagnetic spectrum. On figure 3.1, write the names in infrared, radio, ultraviolet, X-rays in their correct position. We've got gamma at this end, which is the really short waves, so this is the X-ray. Then we've got UV, visible light, infrared, microwaves, radio waves. Okay, you either know that or you don't, and if you don't, you can't do it. The boy has 2 inflated rubber rings, one black and one white, which he has left on the hot beach in the sun. Figure 3.2 shows the 2 rubber rings. Explain why the temperature of the air inside the black rubber ring rises more quickly than the temperature of the air inside the white rubber ring. Okay, so it's the idea that black surfaces absorb. Okay, got to be careful with the wording here. It is not attract. So they absorb radiation better than white. Okay, so black surfaces absorb is the key word. Someone has left some broken glass on the beach. The curved glass acts like a lens, focusing the sun's rays into a piece of paper and setting it alight. Figure 3.3 shows a lens focusing the rays of light. Use a label line and label P to label the principal focus. Okay, so our principal focus is there, okay, where those lines meet. The lens produces a real image of the sun. Describe the difference between a real image and a virtual image. So the idea is that a real image can be formed on a screen. Figure 3.4 shows a penguin walking on the beach. The penguin has a weight of 20 newtons and each foot has an area of 12 centimetres squared. So there's the key bit that you might get wrong. Each foot is an area of 12 centimetres squared. Calculate the pressure exerted by the penguin on the beach when it is standing on both feet. State the formula and show your working. So pressure is force over area, and our working is, we've got 20 over, and 1 foot was 12, so the other is 24. 20 over 24 gives an answer of 0.83 newtons per centimetre squared. A scuba diver is swimming in the sea near the beach. Figure 3.5 shows a scuba diver, in case you didn't know what a scuba diver looked like. The scuba diver can breathe underwater because she carries a cylinder of air on her back. Air is a mixture of gases. The molecules of gas in the cylinder move randomly. Describe how the gas molecules exert pressure on the walls of the cylinder. So we've got 2 key ideas here, that the molecules collide with the walls, And for a pressure, we need a force. So the force of collision creates a pressure. Okay, and pressure and force is the key word there, so you must use the word force. The cylinder contains air at a pressure of 20,000 kilopascals. The volume of the compressed air in the cylinder is 0.015, etc., etc. Temperature does not change. Calculate the new pressure of the air. State the formula and show your working. So we're looking to use P1V1 is P2V2, and our working would be 20,000 times 0.015 is equal to P2 times 0.065, so there's 0.065, there's 0.015, and that gives us a pressure of 4,615 kilopascals. Okay, moving on to the next question, question 45. An astronaut has a mass of 70 kilograms on Earth, where the gravitational field strength is 10 newtons per kilogram. The astronaut is trained to go to Mars. Gravitational field strength is 3.7 newtons per kilogram. State the astronaut's mass on Mars. Explain your answer. It's 70 kilograms because mass does not change with gravitational field strength. Okay. At one stage during the journey, the mass of the rocket will be 1.5 million, and the speed of the rocket will be 2,500 meters per second. Calculate the kinetic energy of the rocket in kilojoules. State the formula that you're using and show your working. So the formula you're using is a half mv squared. Our working is going to be a half times 150,000,000 times by v squared, so 2,500 squared. Okay, and that on your calculator will give a value of 4.6875 times 10 to the 12. Okay, but because this answer is in joules and it says give the answer in kilojoules, the actual answer is 4.6875 times by 10 to the 9 kilojoules. Okay, because a kilojoule is 1,000 joules. C. The astronaut remains in communication with the Earth on his journey to Mars using radio waves. State one reason why it's impossible to use sound waves for communication between the astronaut and Earth. Okay, so the idea is that sound needs a medium, a material to travel through. Okay, and space is a vacuum, so there is no medium for the sound waves to travel through. Where Mars is 2.25 times 10 to the 8 kilometers from Earth, the radio signals take 750 seconds for a radio wave to travel between Earth and Mars and Earth. Show that the speed of the radio waves is 3 times 10 to the 8 meters per second. So basically we're doing a speed equals distance divided by time question here. And so we've got 2.25 times 10 to the... Now I need to be careful here because this is in kilometers, and so it's times 10 to the 11 over 750. Okay, which is 3 times 10 to the 8 meters per second. And then state the speed at which infrared radiation travels. Well, infrared is an electromagnetic wave. It travels at the speed of light, okay, which is 3 times 10 to the 8, which is the same as the previous answer. And finally, an archaeologist digging at an ancient site discovers a spoon. The spoon is made from an unidentified material. The archaeologist suspects the spoon is made of metal. She places it above a flame as shown below. She notices that the handle of the spoon quickly becomes very hot. State why this observation supports the suggestion the spoon is made of metal. Basically, metals are good conductors of heat. Next question is, the archaeologist is arrested for destroying a priceless artifact that she's found by sticking it in a Bunsen burner flame. No. Part 2, describe in terms of its atoms how thermal energy is transferred through a metal. So, at the hot end, molecules vibrate more. Okay, those molecules collide with neighbours. Okay, and the kinetic energy is passed on. Okay, those three ideas. So more collisions, they collide more with the neighbours, move more, vibrate more, collide more with neighbours, and that's passed on. The archaeologist hopes by determining its density she'll be able to identify the metal. Describe a method for determining the density of metal from which the spoon is made. So, some key ideas for the 4 marks here. We need to find the mass. Okay, and we'd find the mass using the balance. We then immerse the spoon in water. Okay, and we determine the volume by looking at the increase in the volume of the water. Okay, or we might have it overflowing. Okay, so something to do with determine the increase in the volume of the water that it's in, or look at how much is overflowed, and then we apply the equation. Density is mass over volume.